In 1947, a rather unusual experiment took place at a Hampshire airfield. The results started a line of research that has helped keep Britain in the forefront of modern aviation. On board, a crew member nursed a balsa wood version of the schoolboy's paper dart. 500 feet below, a group of them watched. "20 years later, that skydiving wooden dart had turned into this. Mighty Concorde, the world's first supersonic airliner. That Hampshire airfield was the Royal Aircraft Establishment at Farnborough, which every 2 years is at home as the British aircraft industry's latest products are put through their paces. This is the Farnborough that everyone knows, the place to bring the wife and kids on a sunny afternoon. A chance for a few short hours to be part of the exciting, incredible world of flying. It's a spectacular way of showing the world what's new in the sky. This is the showbiz side of Farnborough, but it's really just the tip of an iceberg. The real heart of the place is buried in this rambling collection of buildings. They won't ever win an award for their architecture, but what goes on inside them is the main reason for Farnborough's existence. The never-ending quest to make flying faster, more efficient, and most important of all, safer. This is where Europe's largest team of aeronautic scientists and engineers devote their talent and energy to the painstaking routine of aerospace research. Their brief is to find solutions to problems before they occur.
BOC announced the departure of their flight 718 to Rome, Beirut, Delhi, Bangkok, Singapore, Perth, and
When you travel by air, your chances of getting killed in a crash are currently 1 in 200 million miles of flying. At present speeds, that means you'd have to be airborne continuously for about 160 years before your number came up. The reason for this is the continuous research by governments and industry into every aspect of aviation, in the air and on the ground. Research is also the reason why you can now fly to New York for half what it cost 20 years ago. And the then 5-day flight to Australia now takes only 24 hours. It looks spectacular, even frightening, but the fact is that traveling by air is one of the safest forms of transport there is. In between test flights, 002 lasers long and sleek in her West Country lair, a devoted retinue dancing constant attendance. Although military planes regularly fly faster than sound, travelling in Concorde will be the first time that fare-paying passengers will have this awesome privilege. Will it be safe? The answer is yes, as never before. Because of the completely different task it will have to perform compared with all previous airliners, Concorde's flight problems have been more fully researched than any previous aircraft in history. This piece of metal was on a military aircraft which flew through a rainstorm at a mere 500 miles an hour. The pitting of the metal is due entirely to the impact of the raindrops. This sample of windscreen glass endured the same rain for a few short minutes. This radome is made of specially toughened plastic. It's the nose of a supersonic fighter that got caught in a shower. It's unlikely that at Concorde's colossal cruising heights there'll be any rain. Unlikely, but just possible. So what happens when an aircraft hits rain at Mach 2 must be carefully examined and understood, and then the cure can be found for a problem that may never arise. This scientist is making an artificial cobweb from perspex dissolved in aniline. This apparatus makes a drop of water the exact size he wants. With this nitrogen gun, he'll fire a piece of perspex to hit that water drop fair and square at the speed of sound. This camera will film the moment of impact at the unbelievable speed of 8 million pictures in 1 second. The 800 miles an hour perspex bullet is stopped almost instantly by these rubber washers. And this is a micro photo of the damage done by just one little raindrop. Now let's see the high-speed film. The scientists have discovered that as the drop spreads sideways, it accelerates to 4 times the impact speed. In this case, that's 3,200 miles an hour. This powerful electric motor of some considerable vintage was once used for testing propellers. Now it helps the Concorde program by whirling samples of material around at the speed of sound. And rain can be added to taste. When Concorde flies in commercial service, it will be the world's first aircraft to have a certificate of performance in rain. Farnborough is a living scrapbook of aviation history. Everywhere there are relics that were once milestones of aeronautic science. This gently mouldering pile, now a desirable residence for starlings, was once a noble comet of BOAC. 17 years ago, when the world's first jetliner started crashing mysteriously, Farnborough was brought in to mount one of the most expensive investigations ever. In these tanks, a complete Comet airliner was hydraulically battered to pieces within a few weeks, the equivalent of a lifetime's wear and tear. Other Comets stood by but were never needed. Now they lie under the trees, cocooned and blind. Concorde is to have similar treatment, and even now the torture chamber is nearing completion. Somewhere down there is a complete Concorde. She'll be able to cruise at Mach 2 without leaving the ground. Her skin will heat to 300 degrees. Within 10 minutes it can be cooled to 50 below zero. conditions she'll actually endure in service. In a quiet corner of Farnborough's spacious grounds is a hangar which is said to be haunted. This was once an RAF jet fighter. It crashed in Holland soon after takeoff. It hit the ground at about 450 miles an hour. Its fuel tanks exploded. More than 200,000 pieces of the fatal jigsaw puzzle that was once a powerful warplane have been scraped out of the Dutch clay and shipped back here to one of the most specialized detective squads in the world, the Air Accident Investigation Department. First, the seemingly impossible job of sorting and identifying the parts, but they quickly established some kind of order from the chaos. Here is an engine, here the undercarriage. This silver spaghetti is the remains of the hydraulic system, the powerful liquid muscles vital to the operation of a modern aircraft. The instruments are carefully set on one side, their readings frozen forever at the moment of impact. The story that an expert can read in these battered dials and bent needles may tell him all he needs to know of those last hurtling seconds to eternity. Freddie Jones, head of the investigation team, is part aeronautics engineer, part detective. With the help of the manufacturer's manual, he painstakingly reconstructs the shattered aircraft piece by piece. Already the larger and more recognizable lumps of wreckage are in position. Although a thorough knowledge of the complexities of aeronautic engineering are essential in this work, he would be the first to admit that simple, intelligent deduction forms the framework of their investigations. The shattered engines are filled with Dutch soil. This tells him that they were running at the moment of impact, so engine failure or fuel starvation can almost certainly be ruled out. This bent wing indicates the angle at which the aircraft hit the ground and what the pilot was trying to do at the time. This aircraft was in good heart and well maintained to the exacting standards of the Air Force. The crew was skilled and experienced. The reason for the crash must be discovered. Two men died in these ejector seats which were still in the aircraft when it crashed. The seats will be checked to see if they malfunction. If they did not, it will indicate that the fault occurred so quickly that the crew hadn't time to eject, a line of inquiry that may yield results. Outside the hangar, a graveyard of broken aeroplanes. If there is such a thing as ghosts, then they'd probably walk here. For this is the aftermath of tragedy, the debris of sudden disaster. Almost always the reason for the crash is found, sometimes sooner, sometimes later. It may be that most of the 250,000 scraps of metal confetti will have to be scrutinized before they give up their secret. Or perhaps the expert has made up his mind from the pieces already assembled. His report, when it is completed, will eventually be circulated to all those whose business is aeroplanes in the air. Out of this tragedy, another microcosm of knowledge will be added to man's store of aeronautic experience. This Boeing 707 is landing on 3 engines in a strong crosswind. There are no passengers on board. It's a training flight making use of the longest runway in Britain. This is Bedford, an offshoot of the Royal Aircraft Establishment. Here also is the Blind Landing Experimental Unit, concerned with research and training in landing aircraft in poor visibility.
Okay, the approach we're going to do.
In this special simulator, a BEA flight crew is practicing landing in thick fog.
Between 200 meters and 400 meters. The altitude time again will be 12 foot above runway 7, and the procedures and calls we'll be using will be your normal procedures. Okay?
Right.
And as soon as we get a call from ground, we'll proceed to this approach.
Okay.
You okay here?
Yep, right.
The simulator can be made to reproduce any flying conditions.
Beeline 994, clear for ILS approach on runway 36, wind 180, 6 knots.
The computer is programmed with the desired amount of fog and the cloud base height selected.
There's a glide coming in.
Looking through the eyepiece, the pilot sees exactly what he would in these conditions. The instruments register the real thing. Even the noise of the engines is reproduced and changes according to the throttle setting.
There's a marker, bit high the marker. 994 is the marker inbound.
994, clear to land, RVR 400, 350 meters.
994. Another high rate this time.
So, the prime land.
Roger. No, it's better now.
Speed's okay.
Yep. The radio on.
Beeline 994, RVR now 350 meters.
994, 350.
500 radio. Auto land, 12 feet.
Height, 200 feet. Soon they must see the runway light.
Right above.
Land. Idle. And reverse.
A good landing in very poor conditions. The crew relax, but in a few minutes they'll be at it again,
Any green light?
practicing endlessly against when they do it for real. All types of aircraft are constantly coming and going at Farnborough. None of them joyriding, all are involved in some aspect of air research. This Buccaneer is going out on calibration tests. One of the most difficult tasks a pilot has to perform is flying at night. How much easier and safer if only he could see in the dark. This television camera has been fitted with a special device developed at Farnborough. This is an aerial view of a model airfield seen by our film camera. Now we light a candle and turn out the film lights. As one would expect, nothing. But here's what the low-light TV camera sees. Soon they will be trying it in a helicopter, and the pilot will be able to see the ground he's travelling over at night on a television screen. Appropriately, the first powered flight in Britain took place at Farnborough. In 1908, the intrepid Colonel Cody flew just 463 yards from this exact spot. Another offshoot of the Royal Aircraft establishment is on the Welsh coast in the shadow of Snowdon. Here they fly a very curious little aircraft. It's the Jindevik, a pilotless radio-controlled target plane. It's built in Australia, and the strange name is Aborigine for the hunted one. As it is towed to the takeoff point, the crew who are going to fly it make their way in the opposite direction. The takeoff trolley is placed accurately in position. The ground staff start their checkout as the flight crew arrive at the control center. In the flight control room, every detail of the aircraft's condition is relayed to the crew by radio telemetry.
Telemetry okay. Let me know when you're ready, flight.
Okay, skipper. Okay to connect fuel lines. Roger. Fuel connected, skipper. Electrics okay. Permission to start engine.
You're to control. Okay to start engine.
Okay to start engine. Roger. Engine running. Telemetry normal.
Revs 5.
Until the plane is airborne, it is guided visually down the runway by a pilot who remotely controls gyro steering in the takeoff trolley.
Stand by for takeoff.
Revs 12.5. Climbing.
All okay, sir. 50 knots. 75. 100. 125. 150.
You have a skipper. Bearing 250.
Roger, 250.
These aerials transmit commands to the aircraft and receive the telemetry information which is displayed to the flight crew.
Now 350 knots. Let me know when she's in visual contact.
Should anything go wrong during the flight, the Jindevik can be instantly destroyed to prevent it crashing into a populated area. And so back over the holidaymakers and the caravan sites. Jindevik has no wheels. It lands on a hydraulic skid on a specially toughened runway. Farnborough is a whole township dedicated to one aim, the safety and efficiency of flying. In the near future, airline passengers will be streaking across the skies at twice the speed of sound. That they will do so in comfort and safety is due in no small measure to those scientists and technicians.